Hi, my name is Pierre with the Analyzer team. This is the third part of our series exploring how to build a propensity model. Today we'll cover three topics, all focused on interpreting the results of your propensity model. First, we'll look at driver rankings, also sometimes referred to as feature importance chart by data scientists. Then we'll look at interpreting your confusion matrix. And last, we'll look at error metrics and how to understand them. All right, let's dig in. We are now ready to look at the results of our propensity model. We'll start with driver rankings, simply because it's the easiest, most visual way for you as a business analyst to make sure that the results make sense and that they align with your own experience of the business problem you're trying to solve. Sometimes these are called feature importances by data scientists, but most business people would call them business drivers, hence driver rankings. We can see in this case that a lot of the demographics we expected to pop do pop. So education, marital status are particularly important. The number of children or teens in the home will also matter as an indicator of whether, in this case, my prospects will respond to my marketing campaigns or not. Next, let's look at the confusion matrix in the bottom center section of the screen. It's an easier way to understand how well your model is doing. Keep in mind your model is never going to be 100% correct. The question is, how good or bad is it? In this case, you can see when we use the validation data set that we got about 853 correct negative predictions and 94 correct positive predictions. We did get false positives and false negatives, of course. We got 83 false positives and 78 false negatives. That gives you a feel for how good your model is. Next, we need to think about what is accuracy. The best place to start to understand error metrics is actually the confusion matrix. Remember, we just looked at it, and we said that we had 853 correctly predicted negatives and 94 correctly predicted positives. So from a purely accuracy standpoint, it's actually pretty good. It means 86% of the time, I'm predicting things correctly. Accuracy, however, can be really misleading. Imagine that we would have a positive outcome truly 1% of the time, and 99% of the time we'd have a negative. I can have a really dumb model that simply predicts a negative every time. That model is going to be correct 99% of the time. Is it a good model? No, of course. So how do we think about it? Well, the way to think about it is to actually look at, of the true positives, how many are correct? And that's what your recall is. In this case, it's 94 versus 78. And then of the predicted positives, how many are correct? And that's what your precision is. It's 94 versus the 83 number that's there. And often in practice, what people do is, rather than think about recall and precision, they combine it into a combined score called the F1 score, which is a fancy average called the harmonic average. And so when we look at these numbers, you can see that in terms of key metrics, the accuracy for this model is 86%, which is okay, but not great. My precision and recall are about 53, 54%. And that means that when I look at positive outcomes, roughly 54% of the time, I can rely on the fact that I'm catching 54% of the true positives and roughly 54% of the predicted positives are correct. That's a better way to think about how good your algorithm is, and that's why the F1 score here is 54%. This completes the last session of our series on how to build a propensity model. Today, we covered driver rankings and what they mean. We looked at the confusion matrix and how to interpret it. And finally, we looked at error metrics. That's it. You should now be ready to go build your own propensity model. So go ahead and try it. As always, feel free to reach out to us if you have any questions. If you'd like to learn more, feel free to check our blog at analyzer.ai/blog.